So, bonjour tout le monde. Hello, I'm very happy to see you here today. Je suis très heureuse de vous voir ce matin. My name is Kim Moir, and I'm a staff release engineer at Mozilla. When I was invited to a conference in Montreal in January, I didn't flinch a bit because I'm from Ottawa, so we have the same weather, so it's great. I've been paid to work in open source since 2001, and that's really cool. Before that, I worked in government, education, and a lot of other tech companies. And before that, I was a student like all of you. But that was a long time ago, and we didn't have all the world's information in our pocket and a phone. We did have email, we did have the web, but that's about it. So if you've heard of Mozilla before, you've probably heard of it as the people who make Firefox, the open source web browser. We also have a foundation which has a mission to make the internet open accessible to all. They work on stuff like net neutrality. As a release engineer, I don't work on the Firefox codebase itself. I write tools to scale out our large build and release pipeline that transforms Firefox code into a shippable product. So a lot of people compare release engineers in terms of a factory. We're the ones that actually take the raw materials and make it shippable and give it to the world. So this build and release pipeline is a large distributed system, and we are constantly optimizing it to be more scalable, more resilient to failure, and modifying the services it provides. Outside of work, I like to run long distances, often in the snow, because I live in Ottawa, and I like to bake cakes. I put these pictures up here because I find in our industry, like, there's this huge thing, like, you should always be working, you should always be coding, you shouldn't have a life. And I like to disprove that. So I have a family, I run marathons, and I like cake, and I like Python too. So today, the agenda, we're going to talk a bit about the life cycle of code. We're going to talk about distributed systems, which is my favorite thing. We're going to talk about replacing components of a running distributed system in terms of this huge rewrite that we did for the Firefox build and release pipeline the past year. And we're going to talk about how you can try stuff like this with your projects. So let's get started. A month ago, I gave a talk, and I had a Mindy Kaling quote, and so it went well, so this is my new thing. I have to have one there. So let's talk about distributed systems and create some memories. So, hands up, how many of you have worked with a completely new code base in a work contest? One? Okay, and how many of you have worked in an existing code base? See, that's a much bigger number. So I noticed, like, I've mentored a lot of interns, and one thing I notice is, like, they come and they're all like super enthusiastic and stuff, and then they see this large code base that they have to deal with, and it's really scary. And that's because in school, like, you're going to learn new UI concepts, you're going to learn new frameworks, you're going to learn new language semantics, but you do that in the context of a small project. So when you get to a company, you have like a large new code base, and it's kind of overwhelming. So it's a really important skill to learn how to work with an existing code base. I try to think of this like walking through a forest. Sometimes you're walking through it for a couple hours, sometimes you're walking through it for a couple days, sometimes you walk for a couple weeks and you get really muddy and you get really hungry, but you have to go and walk through the code base and understand how it works. And one of the most important things is to talk to other people, like the other people that have worked on the code base. What do they know? What can you learn from them? I find that asking a lot of questions as a software engineer is one of the most important skills that you can have, because if you don't ask questions, you're going to get stuck and you're not going to move forward. So one of the things that I look for when I look at a new code base and a team, and I'm a release engineer, so I'm really biased because all I really care about is shipping. I care a lot about shipping, and I always think if you're not shipping your code, like, it's not real code because it's not out there and people aren't using it. And it's really scary to ship because then other people see it, they make comments, and they be rude, especially in open source, because it's like people are rude sometimes. Sometimes they're nice, but you know, well, you'll probably know. So I look at, is there a documented shipping and deployment process that works for this code? Do you ship new binaries or provide updates on a regular basis? That's super important. Is the code readable? If it's like got all this cruft in it and commented out stuff that no one uses or no one knows about, it's not readable, and then it means no one else can read it and understand it. Is it tested code? Is it correct? Are there correctness, integration, and performance tests? If you're not testing your code and you deploy it, you're not gonna get very good feedback from the people who use it. And there also needs to be a feedback mechanism between developers and users. Like if you use GitHub issues or you use different issue tracking things. There's also like telemetry that you can implement. For instance, in Firefox, when Firefox crashes, we send the crash dump back to Mozilla, and then we analyze it to see, what caused this crash, can we fix it in the future, stuff like that. And then another thing that's really important about code bases is the concept of code ownership. If no one cares about the code or owns the code, then it's not going to get better. So ownership means responsibility for change. It doesn't mean that you have to change everything yourself. You can serve as a code reviewer or you can mentor new people, but people need to care about the code and the people who use and maintain it. And this is really important because someday you want to look at some other code, so you want to have these other people that can take ownership of the existing code that you wrote. So as part of this research for this talk, I looked into some really old code bases. The most inspiring one for me is the code for the Voyager space probe. It had its 40th anniversary last year. It's still being updated, so people actually update stuff on a space probe that's in space very, very far away, which is really cool. Airplanes have about a 30-year service lifetime. When I was the release engineer for the Eclipse project, I talked to some people, and you have to have the entire tool chain saved so that you can compile code that's that old, and you have to have all the compilers working and stuff because you might need to patch software on an airplane. Industrial robots in factories, they last about 20 years of service. The first Firefox release was about 15 years ago. I'm not sure how much of the original code base remains. I often think code is like the human body, how the human body, you're shedding skin cells all the time and you're getting new ones or whatever. And the code base is kind of like that. It's always getting replaced with new ones, and eventually it will die. But there's also social issues with these old code bases. Like for instance, this Voyager probe, it needs last year, the last remaining programmer on the original project was retiring. So they had to find someone who could write code for this really old version of Fortran that it used, which is a really interesting social issue and probably hard to recruit someone like that in 2017. So this is a very simplified version of what happens when a developer lands code at Mozilla. I'm going to switch now to talk about the code rewrite in terms of this pipeline that we did last year. So basically, when a developer lands code, she lands the code, and then a decision graph is generated. And basically, this is just a big graph that has all the dependencies and figures out, okay, do we have everything in place that we need to run everything? If that works out okay, we run builds for Windows, Mac, Linux, and Android. Then we sign them with certificates. Then we run unit tests, and then we run performance tests to make sure everything's okay. And that's just on every commit. That we have all these different branches for different things, but that's what happens. Some metrics on this pipeline that we have. It needs to be up and running all the time for developer productivity. Mozilla is a super distributed company. We have developers all around the world, and it's 7/24. Parts of it do go down from time to time, but I'll talk a bit about that later. We have about 500 commits a day and about 140,000 jobs that get spawned from these commits, because with every commit, we run builds and tests in parallel, and there's a lot of parallelization to get things done as quickly as possible. So one of the most important things for us is end-to-end times, and this is the time from when a developer lands a commit until they're able to ship the finished product. So why is this super important? Well, developers want to be happy, and happy developers can see what they did is working or it's not working, and they want to see it really quickly. Also, it's really important to have fast end-to-end times because small incremental changes reduce risks. It's too difficult to see what went wrong if you have thousands of people committing stuff and then you don't know what happened, so you have to bisect the code and fix stuff. So if you only have a couple commits, it's easier to figure out what went wrong. It's also super important in the context of 0 days. So we need to be able to get security patches to our users quickly. For instance, last week, we released 5 new releases. They all ran the same day because of the Meltdown and Spectre vulnerabilities that were released. This is the scary old architecture diagram that Selena wrote a couple years ago. This is 2014. This is what the release and engineering pipeline look like. You don't have to understand all the little pieces. This is meant to scare you. There was a lot of points of failure and a lot of things that could go wrong. So we decided to rewrite it. So at that time, it took around 11 hours to ship a release from the time a developer landed to commit to builds being available to users. And now it takes 4 to 5 hours. So why do we do this? Why do we do this rewrite? We wanted to have developer autonomy. Before, people had to go through us to change the configuration builds and tests, and that's just not tenable in a large organization. We want to be able to file faster if people committed stuff that didn't work. We have stuff in place now that will fail it quickly and not spin up a bunch of instances to run builds. We want to have better local testing. We want to change our whole technology stack. One of the things that we did that was really useful was that most of our stuff runs on Docker now, so developers can check out a Docker image and run exactly their builds or tests as they would on our CI farm. And of course, because we're in technology, we want to learn new things. Reasons not to rewrite. Failure is super likely. I don't know if you've been following the story of the Phoenix project in Ottawa with the federal pay system. It's kind of a poster child for not how to rewrite software. So those of you outside of Canada, basically, they deployed software 2 years ago, and many people's pay has been messed up since then. It's also really expensive to rewrite because you're rewriting, instead of putting new features in your product, you're actually rewriting the whole stack. And you also may lose people on your team who aren't interested in working on a new technology stack. I know at our organization, we've had people that decided, you know what, I don't want to work on this stack, so I'm going to go work somewhere else. So this is a quote from Anne Curry. She writes a lot about distributed systems. I have links to her blog posts at the end of this talk. So this is a bit about distributed systems. And basically, it's a system that spans more than one physical location. And it uses a lot of concepts to make it more resilient. So it uses, for instance, for physical locations, we run most of our builds and tests on Amazon. We run them in different regions. So if Amazon instances in Oregon all went down, we would still have ones in the east coast of the US app that we could run builds on. We also have decoupling. Decoupling is super important, and basically it means that services that run are not necessarily dependent on all the other services being available. So this is really important, so you can bring parts of the system down and up. And it's also very useful when you're trying to change parts of the system. And these services that are decoupled, they talk to each other via APIs. And so you can change the structure and rather, you can change the implementation of the underlying service, and as long as the APIs stay the same, they can still talk to each other. So how did we at Mozilla approach migration for this large build and release pipeline that we have? So I worked on migrating a lot of the, Linux, Android, and Mac parts. And what we would do is, we have this big system. We had an old system and a new system. And we would move parts of the pool and communicate with everyone, this is what we're going to do. This is what how long it's going to take. We had a checklist for all the steps we were going to take. We would migrate stuff. We'd monitor capacity and wait times, which means how long developers have to wait for their test results. And then we would monitor state after migration. We'd also have a rollback plan. So if things went south, we would roll everything back to the old system. So we did that a couple times. And we would, after everything was okay, we would decommission the old and move on to something new. So this is one of my favorite slides. I saw it at LISA, which is a Large Installed Systems Administration Conference in 2015, and Jez Humble was there. He is the author of a book called Continuous Delivery, which if you're in my space is really awesome. It's basically a textbook on how to deliver software. And this picture is by Martin Fowler, who's really famous for writing this book called Refactoring. So this basically talks about the strangle application and how you have to kill parts of the old system incrementally and migrate them to the new system to do that. So I'm just going to read something. One pattern that is particularly valuable in this context is the strangle application. In this pattern, we iteratively replace a monolithic architecture with a more componentized core by ensuring that the new work is done following the principles of a service-oriented architecture while accepting that the new architecture may well delegate to the system it is replacing. Over time, more and more functionality will be performed in this new architecture, and the old system being replaced is strangled. So in Mozilla Relenge, one of the things we did was we wrote a dispatcher application that allowed us to schedule jobs on the old system, but the scheduling function ran in the new system, so it allowed us to do that. So what did we learn through this whole migration? Basically change one thing at a time, evaluate and change another. Expectations change a lot. So one of the things that happened was that we suddenly could build everything really fast. And so marketing thought, hey, these people can build stuff really fast. We'll just say that this new Firefox will be available at this time and date, and that's what's going to happen, and nothing's going to go wrong. And that was surprising, but we did make the date, so that was okay. Another problem is it's the staging environment we didn't have to test this whole new system, so we had to set that up. And we also had to communicate a lot. And the other thing is that organizational changes happen. Like as I mentioned, people sometimes don't want to work on something new, they want to work on something old, so they go work something else. So deleting code is one of my favorite things to do. And this is how you do it. Basically, you have to communicate with people, like, you know what, I'm going to get rid of this. If it's a large module or something, like if you have mailing lists or Slack channels or whatever in your organization, you should say, hey, I'm going to delete this. Is everyone okay with that? And delete the code. Don't just comment it out, because it's 2018 and version control is your friend. So you can just bisect and see what's missing if you do that. You can also update or delete relevant tests. Like, don't run a bunch of tests that aren't relevant anymore, just get rid of them. And also look at your dependencies. Can they be updated or removed? If you're deleting old code, you can probably update some libraries. And then celebrate, because you've got rid of code. So, you know, sometimes you get emotionally attached to code. Like I worked on this thing for like 3 years that basically was code to run automated tests on mobile. And then I had to delete it all. But that's okay, because then you get to work on something new. So that's okay. Just accept that's part of it. So how can you apply those principles yourself? When you work on a new project, think about the life cycle of code. What is the update strategy? What's your deployment strategy? How can you find out if your users are unhappy? And how can you distribute code ownership so that when you decide to work on something new, there's other people to take that over? My final thought for this talk, I've worked in software for 20 plus years and I've survived, so you can all too. But one of the most important things is that code in the long run is not really that important. Well, it is, but a larger issue is that the relationship with people you work with is really important, because they might work at the next place you work with too. So jobs are short, careers are long. The only real thing is relationships. Mozilla is hiring. I have lots of stickers. That's about it. And I mean, I have 200 stickers. I wrote to university recruiting and said I'm going to this talk. This conference is all students, and I said 600 people who were coming. And they're like, oh great, we'll give you 200 stickers. So please come and see me if you want some.